In this lecture, we will discuss various applications of CRO. In the past lecture, we have studied various parts of CRO, block diagram, functioning of each part of CRO, the meaning of deflection plates, the meaning of deflection of electrons. Then we have also discussed time-based circuit, how to add these circuits, then triggering. Today we will discuss various applications. The aim of this lecture is to discuss many applications to find voltage and many other things, and we will also discuss Lissasu's figure which can be obtained on CRO. First and most important application is measurement of DC voltage. We can measure DC voltage using CRO. For this, initially trace is adjusted to the center of the screen. The DC voltage that you want to check is applied on Y input. The trace will be there, which will deflect in an upward or downward direction depending upon the polarity of supply voltage. The deflection is noted and multiplying it with deflection factor. The deflection factor is given just near the knob, and this is in volt per centimeter. The output of the screen is similar to your graph paper. Some grids are there, squares are there, so by which we see the distance and we multiply with deflection factor voltage in volt per centimeter. The magnitude of unknown voltage can be obtained. Suppose you apply voltage 10 volts per centimeter and your trace, you just measure the trace by scale, and the trace is suppose 12 or 1.2 centimeter, then 1.2 into 10 will give you 12 centimeters. So this can be checked just like this. AC voltage can also be measured using CRO. Again, the trace is adjusted to the center by moving the knob. There is a knob for X deflection and Y deflection. You can move the knob on the center, and then the voltage is applied on Y input. The peak to peak distance is measured. A vertical line will be there. So just measure from top peak to bottom peak distance and multiply it with deflection factor as I discussed in the previous slide. So you will obtain VPP, V peak to peak voltage. Now, if you know peak to peak voltage, I think all of you are aware with this peak to peak voltage. If not, I can draw it. Suppose this is a line and this is your voltage. I'm sorry. This is your voltage, suppose. Then the difference between this to this, the top peak, I'm poor in drawing, but this peak to this peak, this is called VPP. Now, if you know VPP, then you can calculate VP voltage. VP, obviously it is half of this, VP by 2. And if you know these two, then you can calculate root mean square voltage, VRMS, which is VP upon root 2, or V average 0.66 VP. We can measure frequency also. A sinusoidal voltage whose frequency is to be determined is applied on Y. Now the time-based control is adjusted to obtain 2 or 3 cycles in a signal. The horizontal spread is noted. Now if this is multiplied with time-based sensitivity, the time period of the signal is obtained. The reciprocal of time period generally is called frequency. So again, just apply your signal, adjust time-based voltage so that you will get 2 or 3 cycles on the screen. Now the spread is noted and multiplied with the horizontal sensitivity or time-based sensitivity. You will get time period. If you just reciprocate it, you will get frequency. Lissajous figure. You might have heard this. Scientist has discovered very interesting method to create interesting figures, and this figure also gives a lot of information about the voltage applied. This is a method to determine the frequency, is a use of Lissajous pattern. The principle is when two sine waves oscillating in mutually perpendicular planes, and when these two waves are combined, different type of closed loop patterns are obtained, and the form of resultant pattern depend on ratio of frequencies and phase of two waves. The Lissajous figure can be obtained by a CRO by applying two sine waves at y and x plane simultaneously. We apply two sine waves, and we can find unknown frequency of a signal if one frequency is known. To find the unknown frequency of a signal, it is applied to y plate, while a sine wave voltage of known frequency is applied to x plate. Now, by varying the frequency of known source, a stable loop pattern is displayed. Horizontal and vertical tangents are drawn. The number of points at which the loop are touching the horizontal and the vertical, we calculate this. And using this, Fy upon Fx is equal to Lh upon Lv. Lh is the number of points on y or on horizontal, and Lv number of points on vertical. Tangents are noted. So by using this, we can calculate the frequency. Phase difference can also be measured when two sine waves oscillating in mutually perpendicular planes are of same frequency. The Lissajous figure forms an eclipse. This eclipse helps in determining the phase relationship between the two. Suppose two sine waves are there and having different phases. One is V is equal to Vx is equal to V sin omega t, but another is Vy is equal to V sin omega t plus phi. Phi is the phase difference is there. So the eclipse will be obtained. Now, if you note down the A prime and B prime, where it is cutting the x and y axis, or we can say only yes. Look, BB prime is there and A prime is there. If you check BB prime and A prime, you can calculate phase angle, sine inverse AA upon BB prime, and you will get the value of phase difference. We can also obtain this using Lissajous figures. Here Vx and Vi are the instantaneous value applied on x and y. One is Vx sin omega xt and second is Vy sin omega yt plus phi, where Vx and Vi are the amplitude of the voltage applied, omega x, omega are the angular frequencies, and phi is the phase angle. That this pattern can be obtained, and using the pattern, we can obtain many information. The patterns are shown in the next slide. By applying various frequency on x and y axis, we will get this type of figures, either linear figure or elliptical figure or a circular or 8 shape. So by various frequencies, you will get this type of figures. And under what circumstances the figures will be obtained, we have discussed in the next slides. Actually, as per the Lissajous figure, we applied two different frequencies on X and Y plates. Then, when both voltages have equal frequency and are in phase with each other, suppose, then phi will be equal to 0 and omega x will be omega y. If we use this, then we will get the equation of straight line. The pattern we obtain will be straight line. So if your pattern is straight line, you can say now that both are having same frequency and no phase difference. Now, when both voltages have equal frequency but with pi by 2 phase difference, then you will get Vx square plus Vx square upon capital Vx square plus Vy square upon Vy square is equal to 1. This forms an equation of eclipse. Interestingly, either you form equation of eclipse or so if you see an eclipse on the screen, you can say this is both are having same frequency but phi by 2 phase difference. Similarly, in the third case, when two equal voltages having equal angular frequency but pi by 2 phase difference and voltages are also equal, so you will get Vx square plus Vy square is equal to capital V square. And so you will get a circle. If the frequencies are in different ratio, omega x upon omega y is equal to nx over ny, you will have some different image. The closed figure are multiple loops. If the ratio is 1 is to 2, you will get n is equal to 1 and y is equal to 2, you will get figure of 8. Actually, 1 n is equal to 1 and 2 will give you idea how many times it cut the x-axis and y-axis. Many applications are there. It is used in troubleshooting or circuit analyzing. As we discussed in the beginning, then it is called engineer's eye. You can see what is happening in the circuit. If anything is not working or malfunctioning can be seen here just by seeing the signal type of signal or distortion in signal. It is used to creating image in television receiver. In hospitals, medical lines, we use the same CRT for electrocardiography or ultrasonography. It is also used in radar to detect, give position, angle and distance of a target. Thank you. In this lecture, you have studied applications of CRO, This CRO is very useful for exam point of view also. So discuss block diagram and then the applications. In the lab, you can not only you can see the CRO, but can also use for various purposes, for voltage and calculation and current calculations and frequency measurements. Thanks and take care.